Welcome back to C++ tutorial on Tute Fulcrum. This session is on relational and logical operators in C++. Relational operators are used for comparison of two values to understand the type of relationship a pair of numbers shares. For example, less than, greater than, equal to, etc. Let's see them one by one. The equal to operator checks whether the two given operands are equal or not. If so, it returns true, otherwise it returns false. Let's take a program and understand this. So let's take two operands A and B, and let me initialize the values of A and B. Let A be 10 and let B be say 20. And let me use a variable to store the result of this operation. So if I say A equal to B, here it checks for the comparison between A and B. If A and B are equal, the result will hold a value 1, else result will be 0. So in our case, A is 10, B is 20. They are not equal. So the result is expected to hold a value 0. Let's use a cout statement and verify this. So let's build and run and verify our output. So as expected, you can see the result is holding a value 0, indicating that the operands are not equal. Suppose if I change the value of B to 10. Now my A and B are equal. So when I use equal to operator between A and B, the result is expected to hold a value of 1 because my comparison is true. Let's check. Yes, you can see your output here. Now the result is 1. The not equal to operator checks whether the two given operands are equal or not. If not, it returns true, otherwise it returns false. It is the exact Boolean complement of the equal to operator which we have seen earlier. So let me take the same program. Here I'll use the operation A not equal to B. So here my A and B are holding the same value 10 and 10. So if I say A not equal to B, this is a false condition. So my result is expected to give me an output of 0. Let's verify this. So you can see your output here, result is 0 because in this case my A and B, the operands, are holding the same value 10. Now let's modify this. I'll make this back to 20. So now this is holding a true relationship. A not equal to B. Yes, that is true. So here I'm expected to get an output of 1. Let's verify. Yes, you can see the output here. Result is 1. The greater than operator checks whether the first operand is greater than second operand or not. If so, it returns true, otherwise it returns false. So if I write an operation here, A greater than B. So here the operand A is holding a value of 20 and the operand B is holding a value of 10. So I'm checking here what 20 greater than 10. So here my relation is true. Yes, 20 is greater than 10. So the variable result will be holding a value of 1 which we are printing. So let's check, let's verify our output. Yes, the variable result is holding a value 1 as expected. So suppose if I have made this as a small value. Let's say I'm making A to hold a value of 2. Now if I check A greater than B, I'll get a false value because it is checking like 2 is greater than 10. No, this is not true. So the variable result will hold a value of 0. Let's verify this. Yes, result is having a value 0. Less than operator checks whether the first operand is lesser than the second operand. If so, it returns true, otherwise it returns false. So if I write an operation here as A less than B, it checks if the first operand, that is A, which is holding a value of 2, is less than the second operand B, that is holding a value of 10. So 2 less than 10. It's a true relation. So the result is expected to give us an output as 1. Let's verify. Yes, you can see the output here. Result is 1. So now if I change the value of the first operand to 20, it checks for 20 less than 10. So now the relation is not true. 20 is not less than 10. So the result will hold a value of 0. So you can verify your output here. Result now gives an output as 0. The greater than or equal to operator checks whether the first operand is greater than or equal to the second operand. If so, it returns true, else it returns false. So if I write an operation like A greater than or equal to B, it checks if the first operand A is greater than or equal to B, the second operand. So here it checks like 20 is greater than or equal to 10. So yes, 20 is greater than 10. So the result is expected to give us an output as 1 because it's true. Let's verify this. Yes, you can see your output here. The result is 1. So if I change the value of my first operand to 10, now both the operands are holding the same value. So again, if I compute the same operation, what will be the expected output? It will be 1 because my first operand A is greater than or equal to. They are equal. A and B holds the value 10. So they are equal. So I am expecting an output as 1. Let's verify this. Yes, you can see your output here. It is 1. Now if I change the B value to 20, now this relation fails because now A is not either equal to or greater than B. So I am expecting an output 0. So you can see the output here is 0. That is, now my A is not greater than or equal to B. Less than or equal to operator checks whether the first operand is less than or equal to the second operand. If so, it returns true, else false. So if I write the operation A less than or equal to B here. Now it checks whether my first operand A, which is holding a value of 10, is less than or equal to the second operand B, which is holding a value of 20. So it checks 10 less than or equal to 20. Yes, the 10 is less than 20. So we are expected to get an output of 1. Let's verify. Yes, you can see your output here. Result is 1. So if I change the value of A to 20, now also I am expecting an output of 1 because both the operands are equal. Let's verify. Yes, you can see output result is 1. So if I change the first operand to 25 here, so it checks like 25 less than or equal to 20. So now this relationship is false. So I'm expected to get the output as 0. Let's verify this. So yes, you can see the output. It is 0. So this is about the relational operators or the comparison operators in C++. These are mainly used in conditional statements. Say for example, if you have to find the largest of two numbers, you can make use of the relational operators. Say if A greater than B, you can write a statement A is larger than B. Else you can say B is larger than A. Let's move on with logical operators. They are used to combine two or more conditions or constraints or to complement the evaluation of the original condition under consideration. Let's see the available logical operators in C++. The logical AND operator returns true when both the conditions under consideration are satisfied. Otherwise, it returns false. Let's understand this with a program. So we have the operands A and B here. A is holding a value of 25 and B is holding a value of 20. So now if I write an operation like A greater than B, logical AND with A less than B. So this is my first operand and this is the second operand. So if any one of the operand is holding a value of 0, my output will be 0. So if you check A greater than B, that is 25 greater than 20, this will give you a result as 1. So logical 1 and with A less than B. So A less than B means what it is checking? 25 less than 20. So this will return you a 0. So here my second operand is returning 0. So my entire result is going to be 0. So this is going to give you an output as 0. Let's verify this. So as expected, you can see the result is 0. So to understand the working of the logical AND operator, keep this truth table in mind. You have A and B as the operands and let's consider the output for various combinations of A and B. So if your A is 0 and B is 0, the output will be 0. That is, if any of the operand is holding a 0 value, the output will be 0. So if A is 0 and B is 1, then also your output is 0. If A is 1, B is 0, output will be 0. When both the operands A and B is holding a logical 1, then only your output is going to be 1 in the case of a logical AND operator. Logical OR operator returns true even if one or both of the conditions under consideration is satisfied. Otherwise, it returns false. So here, if I replace this logical AND with a logical OR operator. So A greater than B is the first operand and A less than B is the second operand. So A greater than B, 25 greater than 20. So this will return you 1. 1 or with A less than B, that is 25 less than B is 0. So this is returning an output as 1 or with 0. So if any one of the input is 1, you're expected to get an output as 1. So let's verify this. So you can see the output here as expected, it is returning 1. So here also you can consider the truth tables. So if A and B are the operand and this is the expected output for various combination of the operands A and B. So if A and B are 0, your output will be 0. That is, both operands are holding logical zeros. So your output will be 0. If A is 0, B is 1, your output will be 1. Same way, if A is 1, B is 0, you'll get an output as 1. Now both the operands 1, Now also you'll get the expected output as 1. So if any one of the operand is 1, the logical OR returns a true output, or you'll get a 1 output. The logical NOT operator returns true the condition in consideration is not satisfied. Otherwise, it returns false. So if I write an expression NOT of A greater than B. So A greater than B is my operand here. So A greater than B, 25 greater than 20 will return true or 1. So NOT of that, complement of that is 0. So here I am expecting an output as 0. So let's verify. So as expected, you can see the output as 0. If I have given NOT of A less than B. So A less than B is what? 25 less than 20 is false. So NOT of false is what? True. So here I am expected to get an output as 1. Let's verify. Yes, we are getting the expected output 1. Now, let me explain to you short circuiting in logical operators. That is, in case of logical AND, the second operand is not evaluated if first operand is false. Let's consider a scenario like this. A less than B, logical AND with increment of B. So this is the first operand, A less than B. That is 25 less than 20 will return you 0. So if the first operand is 0, the second operand will not be evaluated. So if this is not evaluated, the value of B remains the same as 20. Let's verify our output. So you can see your output here. Result is 0 because if any one of the operand is 0, logical AND returns 0. And you can see the value of B is not changed. It remains 20 because if the first operand is returning 0, the second operation will not be evaluated for logical AND operation. Same way, in case of logical OR, the second operand is not evaluated if first operand is true. That is, if I write A greater than B, logical OR with plus B. So this is my first operand. So A greater than B, 25 greater than 20. Yes, it's true. So it returns logical 1. So when the first operand is returning 1, the second operand will not be evaluated. So my B value remains the same if I print it after the evaluation of this operation. Let's verify. So yes, you can see your output here. Result is 1 because if any one of the operand is 1, logical OR returns 1 and B remains same as 20 because if the first operand is 1 in the case of a logical OR operation, the second operand will not be evaluated. So this is about the relational and logical operators available in C++. Thank you so much for watching. Please do like, share, comment and subscribe, and please don't forget to tap the bell icon. You'll get notified whenever we upload our new videos. Thank you.